let us invite our next speaker, Sir Kumar, Regional Business Leader, Manufacturing of Microsoft Asia. I believe almost everyone here knows about Microsoft, but maybe not so much on how they can help with the advancement in the intelligent manufacturing for the semiconductor industry. So let us invite Sir to give us a presentation on the future of intelligent manufacturing in semiconductor industry. Sir, please.
Good afternoon, everyone. My name is Saj, and I look after the manufacturing sector for Asia. I'll talk about the future of intelligent manufacturing in the semiconductor industry, but I'd like to divide the presentation into two parts because not everyone in the audience is in semiconductor manufacturing. Many of you are in the ecosystem. So the first part, I'll talk about what we're doing in the semicon sector and what we're doing in a broader manufacturing sense. Just a bit of history. As you know, we are about 45 years old as a company, and many of you probably know Microsoft as a Windows company or an Office 365 company. But the reality is that today we are in the entire value chain, from semiconductors all the way to end devices. So if you look at our product families from Surface devices, from Surface Pro, Surface laptops, and Surface hubs, moving on to our servers. So if you look at our data centers, we make all the servers that we have in the data centers. So from server manufacturing to IoT and mixed reality. So we have IoT devices from our Azure Sphere on the edge, all the way to mixed reality solutions, which basically is from a HoloLens to now today HoloLens 2. We also are in the gaming segment, as you all know, with our Xbox devices. So we are shipping today roughly about 200 million devices globally, and we are in the ecosystem in semiconductors, and we work very closely with a number of manufacturers around the world. So if you look at the semicon sector, what we focus on is basically three areas, from design to manufacturing to supply chain. And in design, pretty much we work with all the major IDMs as well as the foundries. We recently, about a month ago, we announced a joint innovation lab with the TSMC, especially in the design area, on the high performance compute area for silicon design. And our Azure Silicon Services team works very closely with many of the foundries around the world to offer silicon services. But the focus of today is going to be on silicon manufacturing, where I'll talk about both front end and back end, what we do. Also, some of the partners we work with, so Optimal Plus, that some of you may know of as part of National Instruments, TIPCO, as well as from a maintenance perspective, we also work with a partner called C3.ai. Then, of course, in the downstream, we also have supply chain solutions through our partners. But let's go back to the manufacturing segment. And when we look at our approach towards silicon manufacturing, everything from pre-silicon to front end to back end, and then all the way through the supply chain. If you look at the business challenges in the front end, the fabs in Singapore, for instance, high capex, throughput constraint, security obviously is very, very high priority. Big data, terabytes and petabytes of data that you can generate from the fabs. And then when you look at the challenges that you see there, and our approach is essentially to look at things like predictive maintenance, using big data to analyze the data that you're collecting in the fab, using AI for defect excursion detection, automated SPC, using visual compute, so cognitive services, just as the previous speaker spoke about, predictive yield and binning, recipe changes, flow optimization, and lastly, workforce transformation, especially in this COVID age. On the assembly and test side, we're looking at things like predictive maintenance, big data analytics, predictive yield, post-fab quality, and again, workforce transformation. So if you look at AI, especially as the previous speaker also talked about, we see a large application of AI, and this is still an evolving area in both the front end and the back end. And if you look at from the top left-hand side, maybe from areas like cognitive inspection, basically looking at physical defects in wafers through image recognition, process optimization, basically being able to look at controlling the process by smart routing of the folks through the clean room, looking at process control and optimization, automation for recipes, especially in the silicon epitaxy reactors, machine calibration and tuning, the industrial robots and cobots that you're seeing more and more, using image recognition to automatically adapt those robots to the specific location, cognitive quality, again, using image recognition, process optimization, factory assistance through virtual agents that are could be cognitive services, as well as finally predictive maintenance. So across the areas from front end to back end, you see AI can be applied in many areas, and we're working extensively with many of our customers in these areas. One of the things that we're also focusing a lot on today, not just in silicon, but also across many of our manufacturing customers, is the area of digital twins, often much misused word, but essentially taking the physical equipment and trying to simulate that through a digital model to do various things, to use the model to say what would be a predictive maintenance for that. How do you do autonomous calibration of that equipment? How do you manage excursion detection through the digital model? How do you do process optimization? How do you do fault isolation? So these are all the things that you can do offline on the digital model, and then without, obviously without disturbing the fab and disturbing the production line, then you can go back and apply what you learn in the digital model back to the physical model. In terms of predictive maintenance, we're looking at two areas. Obviously, one on the fab or the backend, and on the other side, you're looking at the facilities. Basically, facilities obviously are a huge part of wafer fabrication, and obviously have their own associated maintenance and equipment downtimes, which have an impact on your production. So we're looking at obviously in terms of maintenance, looking at fault prediction by taking in data from the equipment, driving predictive maintenance schedules, and then also taking in the process parameters to determine what should be the ideal parameter that is set in, taking into account when was the equipment last maintained, what were the equipment parameters, and then basically drive higher yield through my production line. On the other side, in terms of facilities, looking at performance dashboards, notifications, ordering spare parts, anomaly detection, energy consumption obviously is a big area in terms of predictive. So at this point, I will now move on to the broader manufacturing area, and what are we doing in the area of manufacturing across the ecosystem. And please feel free to enter questions in the chat. I will take them towards the end, and we'll leave some time for that. But now I want to spend some time on manufacturing across the customers that we see in the ecosystem. And when we look at this, we're looking at three areas or three steps in the journey towards building more agile factories or building a more intelligent manufacturing platform. The first step, of course, is connected. So making sure that you have the connectivity, the automation. So essentially converting your data that's coming in from the shop floor, transforming the workforce in the workplace, using industrial automation, modern devices, sensors, IoT, all of that connectivity that you need to do. And that's the basic thing that where everybody is doing. Next, we get into the predictive phase where you start using that data, using that whatever you're collecting to drive more operational intelligence, and also to drive specific process and workflow automation to obviously drive more efficiency in the factory. Lastly, we're getting into the more advanced areas of how do you get to prescriptive, how do you do things like digital twins, how do you do resource optimization, how do you drive autonomous systems or autonomous machines, or autonomous platforms, autonomous processes. And that's becoming the new norm in terms of how we're actually working across the manufacturing. And I'll dive a little deeper into each of these areas. And to start off with, let's talk about workforce transformation in the workplace. This is particularly important right now in the COVID scenario, where your first line workers need those tools. You need to be able to support them to remote work, health, safety, and wellness, driving a lot of the process automation through software tools, so you don't need to have that level of human interaction, providing more learning and knowledge management tools for the workers who come on board, or to even cross-skill the limited number of workers that you may have today in the factory. So when you look at that, some of the examples we have, so here's a customer of ours called Alcoa. In their Iceland plant, what they were able to do was use the application called shifts within Teams to be able to drive specific COVID-related protocols. So being able to check in, check out into certain locations, push certain protocols that from a safety perspective, their safety manager was directing, and making sure that the workers are being able to follow those protocols and being able to use the application, not just from a collaboration perspective, but also being able to use all the add-on capabilities within the Shifts application. We've also taken it one step further. We have now, with partnership with Samsung, with the Xcover Pro, which is more of the ruggedized device, enabled push-to-talk capabilities. So through a button that's enabled on the Samsung Xcover Pro device, you can actually do push-to-talk, basically walkie-talkie capability within Teams to allow communication within the platform. So this is how we kind of one example of how we're driving collaboration in a COVID scenario. And next, we look at kind of looking at modern devices, sensors, industrial automation. So contextual collaboration. So we saw an example of mixed reality or augmented reality from the previous speaker from KNS. So we're doing this with a lot of our customers, especially in this current day, with our HoloLens 2 through guided work processes and also through what we call remote assist. So when we look at mixed reality with HoloLens 2, of course, we can enable this on HoloLens, or we can also enable this on both the iOS as well as Android devices, providing the contextual remote assistance when the expert is sitting somewhere else and giving the worker guidance, giving them training procedures, collaborative visualization, so where two people kind of work together on solving a particular problem, maybe in R&D or maybe trying out new layouts, and contextual data access. So where you are in the plant, you get data related to that from the various systems that you have in place. So maybe from maintenance systems or maybe from the process itself in terms of the location-based awareness. I'll now run a quick video in terms of what we're doing in the mixed reality space.
Work today is more complicated than ever. The old ways of training cannot get new employees up to speed as fast as the experienced people are retiring. We need a better way forward. Introducing Dynamics 365 guides. Simple step-by-step instructions are easily written on a PC, and then holographic parts and icons are simply picked up and placed on the machine where the work is happening. From day one, employees are often expected to get work done, but the complexity can be overwhelming. Now, employees can learn by doing. This is a tool that works with existing processes, allowing a manager to get the right guides to their people. The instructions move with the employees, pointing them to the tools and parts they need, showing them exactly where they need to apply them. Employees get up to speed faster, with fewer errors and more confidence. A simple glance moves them through the instructions, meaning their hands are free to do the work. They can learn at their own pace without having to rely on other workers around them. The overall experience is comfortable and intuitive. For the first time, a manager can see detailed information about how the employees are working and how their skills are growing. This makes continuous improvement faster than ever before. All of this helps employees make the complex simple, so they can learn and adapt faster and organizations can stay competitive.
So that was an example of what you're doing with augmented reality. Another story related to semiconductors is ASML. So we work closely with ASML, especially in the COVID scenario where they were not able to send their engineers down to the very expensive EUV machines that are there in many of the fabs. So being able to use HoloLens 2 on the fab with the ASML engineers being able to guide them remotely from Holland, was a key advantage to customers like TSMC and many of the other semiconductor fabs around the region. And there are many customer stories around this, which you can click on the link below that will take you to the ASML specific stories. Of course, it's not just ASML, but we also work with Philips. We work with many other customers, ABB, etc., to drive essentially this remote support capability when engineers are not able to travel and drive productivity. The next area which we're looking at is, I talked about in terms of predictive capabilities, is the operational intelligence. So end-to-end visibility, real-time monitoring, predictive alerting, etc. So one example of that is what we've done with Jabil. As you know, Jabil is a large contract manufacturer. And here we were able to use machine learning to drive or to improve the AOI, the automated optical inspection, which by itself is probably quite fast. But what we were able to do is actually embed the FPGA-based machine learning services on top of the production line, so able to drive high capacity image recognition to reduce the number of false positives. A very quick video to show you what we're doing.
People tend to think of Jabil as a contract manufacturer. We are more than that. We're a manufacturing solutions provider. It's a very difficult business. We help customers with taking a product and building it at scale.
We went to the production site and found out the test machines suffers very high false call, around 30%.
Operators have approximately 2 seconds to analyze each one of these images. For some of the boards, they can have upwards of several thousand components on it.
Human gets tired constantly staring at the same stuff. We thought that was a very good opportunity for us to use deep learning to classify images. The model is actually reducing the workload for operator. For model training, we're using Azure Linux GPU VM, and we're using Azure Machine Learning Services to deploy the model as Docker container. Our pilot is predicting 75% of the past images and can correctly predict 92% of the defects.
It's one of the most advanced predictive projects that we've had going on so far. We've been talking with Microsoft about Project Brainwave.
The early test result from Microsoft has shown FPGA is capable of predicting 550 images a second, comparing with a CPU cluster with 40 images a second.
The potential for Project Brainwave is substantial in allowing us to move forward at scale for machine learning across Jabil. Very exciting.
So this is an example of moving away from traditional machine learning, which is basically a CPU-based service, to using an FPGA-based service to drive the throughput that you saw, about 500 plus images per second. And that's what we're getting into with the Project Brainwave. In the area of process automation, we're looking at kind of empowering people with the workflow and tools, electronic work instructions, maintenance management, etc. And I'll again run a quick video to show you what we're doing in this area, especially in post-COVID.
Returning to the workplace during a pandemic. It's a scenario very few of us have faced, until now. The Microsoft Power Platform empowers safe reopening with the Return to the Workplace solution. Supported by Power Apps, Power BI, and Power Automate, this low-code solution is designed for everyone. Location readiness allows leaders and task forces to quickly make informed decisions using criteria like infection rates and supplies availability. Employee health and safety management empower employees to check in remotely and self-screen before entering. Workplace care management provides health and safety leaders tools to identify potential infections, manage cases to ensure care and quarantine, and notify exposed individuals. And location management help facility managers monitor occupancy, health supplies, safety procedures, and other facility-related best practices. We all want to get back to work and back together safely. Learn how Power Platform can help you return to the workplace with confidence.
So when you look at the return to workplace scenario, especially with more and more companies opening up, we have the entire scenario from what task forces and leaders need to do in terms of managing the facility, facility managers in terms of looking at which are the facilities ready to open, monitoring occupancy, critical supplies, what do employees need to do in terms of check-in, self-screening, space booking, and then lastly, the health and safety leaders in terms of managing cases and exposure. So this is where we see a key part in terms of driving the automation. Lastly, I want to spend a few minutes on the area of resource optimization, particularly because this is becoming a big topic with the digital twins. So process modeling, asset modeling, production planning simulation, process optimization simulation, training simulation. So all of these are capabilities we want to drive using the digital twins. And within Microsoft, we also have a digital twin modeling language that we created to allow customers to be able to create that digital twin of whatever equipment or process that you would see. So when we look at the digital twin and the applications in manufacturing, as I said, the twin is a much misused word. So for us, twin could be a configuration, it could be an asset, it could be a process, it could be a performance, it could be a simulation, and it could be cutting across a product, it could be a factory, across a supply chain, or even smart spaces, smart buildings could be also be a digital twin. And when I want to show this in a kind of a pictorial way, I would represent it this way. And if you focus on the bottom left-hand side, you will see the various types of twins that we have, from process to configuration, performance, asset, and simulation. And if you take a fuel pump, and if you look at the simulation twin, that is how you're trying to simulate that particular pump, maybe using ANSYS or other pieces of software. And then if you look at the bill of material structure for the entire process, which is out here, which is the factory that you see. And then you have the configuration where this pump is actually fitting in. So you have in turbine 1, turbine 2, turbine 3, which is the 3 turbines where you have component F, which is the fuel pump. This is where you have the asset twin. And then within one of those, maybe there's an O-ring that needs replacement with a serial number of XYZ that needs a service change. So that's when you start looking at the performance twin. So this is where we're kind of bringing all of this together to the various twins as configured in this structure that you see. Lastly, I want to talk about autonomous systems, and this is becoming a big area in terms of what we call deep reinforced learning. So here, how do we drive AI to create autonomous systems? So when we talk about autonomous systems, we want to move away from the traditional definition of machine learning, which if you know how machine learning works, it's basically taking large amounts of data to build a training data set, to build an inference model that will then be able to mimic or give you a representation of the actual system. We believe that is probably not the correct way to do it. We want to move towards what we call machine teaching systems, because you have experts on the ground, you have subject matter experts who should be, whose knowledge should be leveraged to build these systems. To give you an example, if you had a kid and the kid was trying to learn either soccer or maybe baseball, you wouldn't teach the kid how to learn either of these games by making him sit in front of a computer and watching 1,000 hours of videos. That's not the way you would teach the kid. You would probably hire a coach and then go through that process of teaching a kid how to learn how to play a game. So similarly for machines as well, we trying to use the expertise that is already there and then put together the simulation model and then learn from the expert and then put that into actual practice. So we're trying to use a simulation engine, and that engine then becomes the driver for the model. So in terms of wafer manufacturing, machine calibration obviously is a big area, and it takes a lot of time in terms of the operator, the experts to calibrate the system, ensuring it's fit for purpose. There are lots of calibration errors, causes machine downtime, causes yield problems. So how do we use the automation, the autonomous learning to create them? That's where we kind of created the system to build that. One of the examples we have is Nouvelle Warco, and this is where we looked at CNC machines and how do you train operators in terms of setting up the CNC machine. So pretty much learning from what they do and then trying to put that together. Lastly, probably the most important thing is when you look at factories, the whole aspect of security takes on a completely different definition. So how do you protect the devices, the sensors, the machines, especially in a high security semiconductor environment? You're very, very conscious about IP theft and making sure that things are not, your knowledge is not taken out. So this is where, or people are not getting into the floor through sensors that they can connect to. So we have a platform called CyberX, a company we acquired, which is an agentless security for unmanaged IoT and IoT devices. So purpose-built for OT. It's basically looking at behavioral analytics, looking at threat detection, ability to connect to a lot of OT protocols, variety of suppliers, deploys in minutes, connects to a stack. We also have a threat intelligence team, which is basically Section 52 within our CyberX company, and then basically large-scale deployments. Lastly, I want to end with how do you engage? So work with us or our partner subject matter expert. Visit the Microsoft Technology Center. We allow a lot of these virtual engagements that are happening today across all the Microsoft offices through either the Microsoft Technology Center or the Executive Briefing Center. And lastly, also we provide a digital strategy engagement in manufacturing, and through our digital advisors, we help customers to transform. And with that, I would leave some of the links that you can go to in terms of how we're driving intelligent manufacturing, creating a resilient and sustainable future. With that, thank you very much.
Thank you, sir. Thank you. So let us look at the questions that are coming for you. So Jay asked the questions about the HoloLens. How do you get the HoloLens to be integrated to different MES system or to a simple PPT slide set or video? Is Microsoft provides the integration solution or just selling the HoloLens? He also has concern about the cost of the HoloLens. So over to you, sir.
Yeah, good question. So we typically work with, as the previous Changpin also said, right? We typically work with the 3D models. So essentially for HoloLens, we're looking at CAD models from other systems to embed that, to embed those workflows, not really to MEA systems. We actually talking to, because it's essentially driving worker training, worker productivity. So we need to get the visualization of the machine into the HoloLens. So we partner with PTC. PTC has a Euphoria platform through which we connect. We also have our own training solutions within Dynamics called Guides that provides step-by-step procedures that can be embedded into HoloLens.
Okay. And then another question from Don. Will Microsoft be focusing on user experience? I think US stands for.
Yeah, of course. I mean, UX is critical to what we do in every aspect of Microsoft. So when you say UX, of course, there's UX within HoloLens. We also have UX within other platforms. So pretty much user experience is embedded into everything we do. I think there was one more question on the price of HoloLens. So today the HoloLens is actually not very expensive, because if you bundle that into our dynamic solution, it comes in a monthly subscription model, which is fairly inexpensive. So I don't think price is a major concern. We are very, very competitive when it comes to HoloLens. We have now ramped up production. We are now rolling out to wave 1, of course, was a limited set of countries for HoloLens 2. In wave 2, we've now rolled it out to Singapore and many other countries in the region. So you're able to buy HoloLens through our distributors, or you can work with us and we can kind of embed that into some of our solutions.
Sure. I think for those who are keen, please feel free to connect with Sa on the LinkedIn platform, and I'm sure he will provide with you more details on this. Right, Sa?
What is the working principle behind Microsoft Surface Buds? You mean our...
yeah, this will be our last question.
The devices, the earphones that we have. So when you say working principle, so what we have embedded that obviously is our Cortana, which is the Microsoft Digital Assistant. So that is something that we have embedded into every one of our devices, whether it's in Surface Notebooks or Surface Buds or Surface X. So every one of them has Cortana. So that's the cognitive assistant that we have embedded into Surface Buds. Other than that, it's basically our own design in terms of the speakers and everything else that we work with. We're also working with other headphone vendors to embed some of the technology. Unfortunately, I cannot name them, but we are now working across a variety of platforms to embed Cortana into devices.
Understand. Thank you, sir. So for those who still have questions for Sa, please feel free to connect with him on the LinkedIn platform, and he will be able to provide with you the answers and more details on the solutions. So thank you, Sa.